Right, so good evening and welcome to today's class. Thank you very much for making time to join us. Today we're going to be talking about Kleene's theorem continuation. Last time on Monday, right, we had a discussion about converting all transition graphs to regular expressions, right? And we did a couple of questions around that. So today we're going to look at the second part of Kleene's theorem, right? So what it says is as follows. So right, what it says is that, right, if we've done FA to TG, we say that was by default number 2. We've done TG to regular expression. What's left, number 3, is now for us to do FA to we need a regular expression to finite automata, right? A regular expression to FA, right? So if we do that, then we complete the whole proof. Now for us to be able to do that, let's first revisit the definition of regular expressions. We say the smallest regular expressions were now in the letters of the input alphabet themselves. So if we are dealing with an alphabet of A, B, then it means that we have got, we can get these as regular expressions. And then the second part, we say that R1, R2, R1 or R2, R1 clean closure, we also regular expressions, right? So it means that if we had initially, if we wanted to draw a regular expression for now, that accepts now it to be initial end and final, and then goes with an A or B to a looping state, right? So this would be a now to one that accepts an A, it will be A final state, and then anything A or B goes to a looping state, and then if you start with a B, go to a looping state, right? So you could do the same thing for B. But then they say R1 or R2 is also a regular expression, right? So we say A or B is also a regular expression, right? So this is the combination of two regular expressions, and they are leading to leading us to a finite automata that eventually looks like that, and then when you've got an A or B, you go there and you do not come back from that. Right, so this is in A or B, and this is the one for just simply an A, and then the one for simply B could look the same. Right. So now what this tells us is, right, we have got a finite automata for regular expression 1, we've got a finite automata for regular expression 2. Surely you should have a finite automata for the union of those two regular expressions, for the product of those two regular expressions, for the clean closure of that regular expression, okay? So to us to demonstrate that, we're going to be using a couple of questions. Right. So we're given this one, and then they ask us to find, let's say we've got R1 and we've got R2 represented by these two finite automata. And the goal is now to find the regular expression or the finite automata for R1 or R2. Right. If the goal is to find this, then we have to do the following. Okay. The first part is we now need to identify, so let's come back one more. Right. If you're looking at union means we want to find words that were accepted by this language and words that were accepted by this language should be accepted by the new language, okay? So we're saying if we had two finite automata and this was the starting state for FA1 and this was the starting state for FA2, we're saying we should have a combined starting state that represents both these two, right? So in terms of that, we're saying if our new starting state is Z1, right, it should be able to represent x1 and y1. Right. So if we make the assumption that it is representing x1, then with an A, if it reads an A, it will go to x2. Okay, and then if it reads a B, it will go to x3. And also, if we make an assumption that this is equivalent to y1, if we read an A, you go to y2. And if you read a B, you go to y3. Right. Then, because x2, y2 is not defined, we can call this z2, say it's representing x2 or y2. And then x3 is z3 is representing x3 or y3. If you are in x2 and you read an A, right, x2 you read an A, you go to x5. x2 and you read a B, you go to x4. y2 and you read an A, you go to y4. y2 and you read a B, you go to y3. Then if you're in x3 and you read an A, you go to x2. If you're in x3 and you read an B, you go to x2. If you're in y3 and you read an A, you stay there. If you're in y3 and you read an A, you stay there. Right, so after doing this, we will see that x5, y4 is uncharted territory, so z4 becomes x5, y4. Then z5 becomes equal to, we have x4, y3, we do not have, becomes x4, y3. z6 becomes, do we have x2, y3? We do not have, it becomes x2, y3. Right. Then, now if you are sitting in x5 and you encounter an A, you stay in x5. If you're in x5 and you encounter a B, you go to x4. If you are in x or y4 and you encounter an A, you stay in y4. If you are in y4 and you encounter a B, you go to y3. So do we have x5, y4? So we are already, so let's label this. This is equals to z2. This is equals to z3. This is equal x5, y4, we say that's z4. x4, y3, we say that's z5. x2, y3, we say that's z6. x2, y3, that's z6. x5, y4 is equivalent to z4. x4, y3 is equivalent to z5. Then if you're in x4 and you encounter an A, right, you stay there, x4. x4 and you encounter B, you stay in x4. If you are in y3 and you encounter an A, y3 you encounter an A, you stay there, y3, you encounter B, you stay there, y3. So this is z5, you remain in z5. Then if you are in x2 and you encounter an A, you go to x5. If you are in x2 and you encounter B, you go to x4. If you're in y3 and you encounter an A, you stay in y3. If you are in y3 and you encounter B, you stay in y3. All right, so this x5, y3, do we have it? No, we do not have it, so that will be z7, x5, y3, z7, and then x4, y3, that is z5. x5 and you encounter an A, you stay there. Okay, x5 and you encounter B, you go to x4. Right. Then we've got x4, sorry. So we take away this one. y3 and you encounter an A, you staying there. y3 and you encounter B, you staying there. So this is z5. And then x5, y3, you are staying in z7. So when you do that, when you cannot generate any other new states, then we say that we've managed to complete the finite automata. From here, we now need to identify the final states. So for union, the final states for both of these need to be final states in the newer finite automata that we're drawing. Okay, needs to be the final state for the newer finite automata that we're drawing. So we need to identify x5. Anything with x5 should be a final state. So x2, x3, x5 final state, x5 final state, right? So I can use a different color here. So x5 final state, x5 final state. Also, anything with y3 or y4 in it is a final state. So y3 final state, y4 final state, y3 final state, y3 final state. So all these are final states with the exception of these two. If you wanted to draw the finite automata for that, we then have Z1, which is an initial state, and then with an A, it goes to Z2. With an A, you go to Z2. With a B, you go to Z3, right? And then if you're in Z2, with an A, you go to Z4. With a B, you go to Z5. Z5, right? If you're in Z3, with an A, you go to Z6. So let's just put this up a little bit. With an A, you go to Z6. With a B, if you're in Z3, you go to Z6. Then if you are in Z4, with an A, you go to Z4. With a B, Z4 takes you to Z5. If you're in Z5, with an A and a B, you stay there. If you're in Z6, with an A, you go to Z7. With an A, with a B, you go to Z5. If you're in Z7, with an A, you stay. With a B, you go to Z5. Then now we need to mark final states. So Z1 and Z2 are the only ones that are not final states. This is a final state, final, 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 and final. Sorry, the last one is not a final state. Yes. So this is the finite automata for the combined two. All the ways that used to be accepted by finite automata 1 are still accepted. All the ways that used to be accepted by finite automata 2 are still accepted by this machine. All right. Okay, let's move on to another one. All right. We want to find the union of these two languages as well. Okay. So in order for us to be able to do that, to apply the same strategy again, we will say we want all the words of this language and all the words of this language to be accepted by the new finite automata that we draw. So, as we said before, the initial state for the new language is going to represent the initial state for FA1 and the initial state for FA2. So, and then if you're in X1 and you encounter an A, you go to X2. If you're in Y1 and you encounter an A, you go to Y2. Okay. If you are in X1 and you encounter a B, you go to X2. If you are in Y1 and you encounter a B, you stay in Y1. So already we now have X2, Y2. We also have X2, Y1. So this is Z2 and this is Z3. Right. And then also, if you're in X2 and you encounter an A, you go back to X1. if you are in Y2 and you encounter an A, right, you stay in Y2, X1, Y2. We do not have that, so we have got Z4 is equals to X1, Y2. So this is equals to Z4. If you're in X2 and you encounter B, X2 and you encounter B, you go to X3. Y2 and you encounter B, you stay in Y2. So this is going to be Z5. So Z5 is going to represent X3, Y2. Right. Then if you are in X2 and you encounter an A, right, you go back to X1. If you're in Y1 and you encounter an A, you go to Y1 and you encounter an A, you go to Y2. X1, Y2 is Z4. And then if you're in X2 and you encounter B, you go to X3. If you're in Y1 and you encounter B, you stay in Y1. So X3, Y1, X3, Y1, we do not have it already, okay? So we're going to have Z6 being X3, Y1. So this is Z6. If you're in X1 and you encounter an A, you go to X2. Y2 and you encounter an A, you stay in Y2. So X2, Y2 is Z2. If you're in X1 and you encounter B, you go to X2. If you're in Y2 and you encounter B, you stay in Y2. So you go to Z2. If you're in X3 and you encounter an A, you go back to X2. If you're in Y2 and you encounter an A, you stay in Y2. So you're all going back to Z2. If you're in X3 and you encounter B, you stay in X3. If you're in Y2 and you encounter B, you stay in Y2. So do we have X3, Y2 is the same as Z5. If you're in X3 and you encounter an A, you go to X2. Y1 and you encounter an A, you go to Y2, which is Z2. And if you're in X3 and you encounter B, you stay in X3. If you're in Y1 and you encounter B, you stay in Y1, so that's Z6. So it is complete now. We do not have anything else to write down. So to draw this, we have got, we need to assign final states. So what were the final states for both of these? Anything with an X3 should be a final state. And then anything with the Y2 should be a final state as well. So there it goes. So in terms of the drawing part, we have an initial state with an A, you go to Z2. With a B, you go to Z3. All right? And then Z2 with an A, you go to Z4. With an A, you go to Z4. With a B, you go to Z5. Right. Then Z3 with an A, you go to Z4. Z3 with an A, you go to Z4. Z3 with a B goes to Z6. Z3 with a B goes to Z6. So let's put it over here. And B goes to Z6. Z4 with an A, you go to Z2. With a B, from Z4 with a B, you go to Z2. Z5 with an A, you go to Z2. And with a B, you stay over here. Z6 with an A, you go to Z2. With a B, you stay in Z6. Final states, initial is not, so Z2 is the final state. Z3 is not, Z4, 5, and 6. These are all the final states. All right. So that's more about it in terms of union. Now let's look at this now in terms of the product of 2. If you're looking at the product of 2, we see the following. So we may need to explain this a little bit. When you look at product. So product or concatenation is something like this. So you take 1 and you take 2 and you end up with 1, 2 like that. So it entails that I have to pass through number 1 first, then get to number 2. Right? So I have to do the work required in number 1 before I get to number 2. So now, if that is the case, right, we are saying given 2 finite automata, right, the initial state of the final or the initial state of the combined finite automata, it will represent the initial state of state 1, initial state of FA will represent FA1, represent FA1, and then the final state will be represented by FA2. Final state represented by FA2. So what this means is that when we build, right, the initial state Z1 will be equivalent to X1, right? And then there's also another portion that I haven't discussed. So this conjoinment, right? So we're going to have, say, X3, Y1 over here, right? So because we are saying that they are sharing a common point, we're saying X3 and Y1, or the final states of R1 will somehow be now equivalent to the initial state for R2. Right? That is what we are saying. The final state for R1 will be equivalent to the initial state for R2 because of the overlap that we're creating when we concatenate. Otherwise, this would then mean that there's a gap in between those that we cannot exploit. So every time that you read X3, right, in this case is given by the example, realize you're also reading Y1. Every time you're reading Y1, you're also reading X3 because they mean the same thing. All right. So let's move on to an actual question. So we said X1 will be equals to Z1. And if you're in X1 and you encounter an A, you go to X2. If you encounter an A, you go to X2. So this will be equal to Z2. So this will be equal to X2. If you're in X2 and you encounter an A, you go to X2. If you're in X2 and you encounter a B, you go to X3, which is the final state, which is equivalent to Y1, okay? Then you stay in Z2 and here you're going to Z3, so equivalent to X3, Y1. If you're going from X3 with an A, you go to X2, Y1 with an A, you go to Y2. You go to Y2, okay? We'll go to Y2. And X2, Y2 we don't have, so we call this Z4. Z4 will be equivalent to right. Then if you're also in X3 and you encounter an A, a B, X3 and you encounter a B, you go to X4, which is not a final state. So you go to X4, and then Y1 engine counter B, you go to, you stick in Y1. X4 Y1 Z5 Z5 is equivalent to Z5 is equals to X4 Y1. So this is Z5. Okay. And then we have as well X2, right? If we've got X2, right, we are going to have X2 engine content A, X2 engine content A, X2 engine content A is staying in X2, and then Y2 engine content A, you are going back to Y1, X2 Y1. Do we already have X2 Y1? We do not. So this will be equal to Z6, which is Z6 is X2 Y1, right? So Y1 is the same as saying X3, okay? Right, then we also have, so we can put X3 over here. Then we also have, if you are in X2 engine counter B, X2 engine counter B, you go to X3 Y1. If you are in Y2 engine counter B, you go to Y1, which is already catered for, and this is X3 Y1 is equivalent to Z3. And then if you are in X4 engine content A, X4 engine content A, you go to stay in X4, and then if you're in Y1 engine content A, you go to Y2, all right? And X4 Y2 is not yet given, right? So we have Z7 for that. So Z7 is equals to X4 Y2, right? Now, if you are in X4 engine counter B, you go to X3 Y1. If you are in Y1 engine counter B, you go to stay in Y1. So X3 Y1 is Z3. So you stay in Z3. If you are in X2 engine content A, X2 engine content A, you stay in X2, right? If you are in Y1 engine content A, you go to Y2. If you are in X3 engine content A, you go to X2. So your X2 Y2 is given by Z4. If you are also now in X2 engine content B, X2 encountering B leads you to X3. Y1 engine content B, you stay in Y1, right? So X3 Y1 is catered for anyway. Then X3 engine content B, X3 engine content B, you go to X4, right? So X4, X3 Y1 we don't have, so Z8 would be X3 X4 Y1. So this is Z8. And then we also have X4 engine content A, X4 in content A, you are staying in X4. Y2 engine content A, Y2 in content A, go to Y1, which is equivalent also to X3. So X4 Y1, you are going to Z8. And then if you're in X4 engine content B, X4 encountering a B leads you to X3 Y1. And then if you are in Y2 engine content B, you go to Y1 again. So you're going to Z3. If you're in X3 engine content A, X3 content A, you go to X2, right? If you're in X4 engine content A, you stay in X4, right? And then if you are in, if you are now in Y1 engine content A, you go to Y2. So we do not have, unless we made a mistake, we do not have Z8, but we do not have that. So I'm pretty sure there's something that we missed somewhere. Let's see. We said if you're in X4 engine content A, you stay in X4, right? If you are in Y1 engine content A, you go to Y2. Okay, so if you're in X3 and you encounter an A, you go to X2. If you're in X3 and you encounter a B, you go to X4. Okay. Okay, so let's add one more. Let's add one more and see what happens. Let's add one more. So this becomes our Z9. Right? If you are now in X3 and you encounter an A, X3 and you encounter an A, you go to B, sorry, you go to X4. X4 and you encounter B, you go to X3, Y1. And then if you are in Y1 and you encounter B, Y1 and you encounter B, you stay in Y1. So X4, X3, Y1 is given by Z8. Right. So Z9, we gave Z9 here is Z9 is equals to X2, X4, Y2. Right. So if you're in X2, and you encounter an A, X2 and you encounter an A, you stay in X2. Right. X4 and you encounter an A, you stay in X4. Y2 and you encounter an A, you go to X3. X3, Y1, X3, Y1, okay? Then now if you are in, so X2, X3, X4, Y1 is now a new state, let's call it Z10, okay? Then if you are in X2 and you encounter a B, X2 and you encounter a B, what do you get? X2, you encounter B, go to X3, and then X3, Y1. If you are in X4 and you encounter B, you go to X3, Y1, right? If you are in Y2 and you encounter B, you go to Y1, so you go back to Z3. Then if you are in Z10, which is X2, X4, X3, Y1, right? If you are in this state in X2 and you encounter an A, X2 encounters A gives you X2, X4 encounters A gives you X4, X3 encounters an A gives you X2, which is already there. Y1 encounters an A gives you Y2. So X2, X4, Y2 is already given as Z9. And then we have got X2 and you encounter B, X2 with a B, go to X3, Y1. And then if you're an X4 and you encounter B, you go to X3, Y1. If you're an X3 and you encounter B, you go to X4. And then if you are in Y1 and you encounter a B, you stay in Y1. So Y1 is already there. So X3, X4, Y1 is equivalent to Z8. So you go to Z8. And then no more new states are formed. Therefore, you can now close it off. So we want to then draw this finite automata. Okay, so initially this is our initial state. Final state is only that has got Y2. So this is a final state, right? This is a final state, and this is a final state. So we've got only 3 final states. So now we need to draw the finite automata for this. So now if we can scale this down a little bit, and then we can now move on to draw the finite automata. So, to draw the finite automata, we're going to do the following. We start with an initial state, right? The initial state goes to Z2, right? So we go to Z2 like that with an A, and with a B we go to Z3, Z3 with a B, okay? So if you're in Z2 and you encounter an A, you stay in Z2. If you're in Z2 and you encounter B, you go to Z3. If you're in Z3 and you encounter an A, you go to Z4. If you are in Z3 and you encounter B, you go to Z5, right? With a B. If you're in Z4 with an A and you encounter an A, you go to Z6, right? If you're in Z4 and you encounter a B, you go to Z3. If you're in Z5 and you encounter an A, you go to Z7. Right, in content A, you go to Z7. If you are a B, if you're in Z5 and you encounter B, you go back to Z3. If you are in Z6 and you encounter A, Z6 encounter A, you go to Z4, right? And then if you are in Z6 and you encounter B, you go to Z8. So you've got Z8. Then if you're in Z7 and you encounter A, you go to Z8. If you are in Z7 and you encounter B, you go to Z3. All right. So now we are in Z8. If you are in Z8 and you encounter an A, you go to Z9. Right. And then if you are in Z8 and you encounter B, you stay in Z8. If you're in Z9 and you encounter an A, you go to Z10, right? You go to Z10. Then if you are in Z9 and you encounter B, you're going all the way to Z3. B. Then if you're in Z10 and you encounter an A, you go to Z9. If you're in Z10 and you encounter B, you're going to so we are supposed to go to jump and go back to Z8 with the B. So that becomes the complete finite automata for the given language. Right. Any problems there? Any questions, any additions, any subtraction? Right, cool. So be careful as to how you link the final states and the initial states, and also how you link them, especially the crossovers. There are points of interest that you need to be wary of. Okay, so let's look at try and see if we've got another question over here. There we go. So we've got another question. So let's try this again. Z1, we say it is equivalent to X1, right? X1, and you encounter an A, you go to, is this not, okay, it's a little bit different. With an A, you go to X2. With a B, you go to X2. So this is going to be our Z2, Z2, and this is going to be X2, right? And then if you have in X2 and you encounter an A, you go to X3, and that is equivalent to Y1. So that's going to be Z3. So Z3 is going to be X3, Y1, right? If you're in X2 and you encounter B, X2 and you encounter B, so this is supposed to be X3, Y1. If you encounter B, if you encounter an A, you're going back to X1. So you're supposed to go back to X1, which is equivalent to Z1. Then if you are in Z3 and you encounter an A, right, you go back to X2. If you're in Y1 and you encounter an A, you go to Y2, right? This is Z4. If you are in Z4, okay, let's Z4, X2, Y2. If you are in X3 and you encounter B, you stay in X3, Y1. If you are in Y1 and you encounter B, you stay in Y1, X3, which is equivalent to Z3. If you're in X2 and you encounter an A, you go to X1. If you are in Y2 and you encounter an A, you stay in Y2. So X1, Y2, we don't have, we have Z5 now. X1, Y2. So this is Z5. If you are now in X2 and you encounter a B, whereas X2 encounter B, go to X3, Y1. If you're in Y2, and you encounter B, you stay in Y2. So this is Z6. So Z6 is going to be equal to X3, Y1, Y2. Right. So now if you are in Z5 and you X1 and you encounter an A, you go to X2. If you're in Y2 and you encounter an A, you go to Y2. So this is Z4. If you're in X1 and you encounter B, you go to X2. If you're in Y2 and you encounter B, you stay in Y2. So this is Z4. If you are in X3 and you encounter an A, you go back to X2. If you are in Y1 and you encounter an A, you go to Y2. If you're in Y2, you stay there. So this is Z4 as well. If you are in X3 and you encounter B, X3 and you encounter B, you are staying in X3, Y1. If you're in Y1 and you encounter B, you're staying in X3, Y1. Y2 and you encounter B, you are staying there in Y2. Right? So this is equivalent to saying X3, Y1, Z6. So we stop here, we are done. The next thing is then to come and draw the finite automata. So for us to draw the finite automata, to identify the initial state, the final state, only those that contain Y2. So we have got 3 final states like that. Right. So next, let's just draw the finite automata and complete this. Okay. So we are doing it as follows. We've got an initial state. So let's choose a different color, initial state, and then Z1, which goes to Z2 with an X2, Z2 with an A, and a B, you go to Z2. And then from here, you go back to Z1 with an A, and then you go to Z3 with a B, right? And then from Z3, you go to Z4 with an A, you go to Z4, and then from Z3 with a B, you stay in Z3. Z4 with an A, we stay. Z4 with an A, we go to Z5. And then Z4 with a B, we go to Z6. Then Z5 with an A, we go to Z4. And then Z5 with a B, we go to Z4. Z6 with an A, we go to Z4. With a B, we stay in Z6. So Z4, Z5, and Z6 will remain as final states as well. All right, cool. So let's stop there for tonight and then complete this in our next class on Monday. Then we'll start more of, we'll do further questions. Okay, enjoy the rest of your evening. From me to you, good night and